This is The Road to Suing Souza, a project by Cassie Durand, Alyssa DeSabato, and Elizabeth Moretto. One day, Mr. Souza was out driving his car, paying attention to everything but the road. A few minutes later, he began approaching a hairpin turn, except Mr. Chuckran had covered it with nothing. He hadn't covered it with anything. Actually, Mr. Chuckran had been sightseeing with his wife by the side of the road. And since he wasn't paying attention, Souza didn't notice him standing there until the very last minute. When he finally did notice, he freaked out, slammed on the brakes, and skidded into Chuckran's car, causing both the cars to fall off a cliff and into Mr. Daigle's giant turkey farm. Mr. Chuckran was so mad, he wanted to bring Souza to court, and we're going to provide the evidence that will prove Souza was speeding. The first thing we had to do to prove Souza was speeding was calculate the horizontal velocity of both cars when they were stuck together and flying off the cliff. In order to do this, we had to use both projectile and kinematic equations. The first equation we used was a kinematic equation. Y minus y naught equals Vy naught times time plus 1/2 of the acceleration times time squared. In this particular equation, we were solving for time, or how long Souza was skidding before he hit Chuckran's Jeep. After altering the equations so that we would be able to solve for time, we plugged in all of our knowns. Y minus y naught, or the height of the cliff, is negative 38.9 meters. The initial vertical velocity of both of the cars was 0 meters per second, and the acceleration of both the cars was negative 9.8 meters per second squared. After we plugged in everything, we got time equals 2.8 seconds. Now that we had the time, and we had the distance, or range, of Souza's skid marks, which was 18.5 meters, we could plug them into our projectile equation, which is x equals vx times time. We came out with the horizontal velocity of 6.6 meters per second. This 6.6 meters per second is how fast Chuckran and Souza's cars were traveling in the horizontal direction once they had fallen off the cliff. Our next step was to plug this information into a new equation so that we could calculate the velocity of Souza's car at the very end of his skidding. But first we had to identify our knowns. We knew that Souza's car, a 2003 Toyota Corolla, had a mass of 1,154.846 kilograms, and Chuckran's car, a 2000 Jeep Cherokee, had a mass of 1,522.709 kilograms. We also knew that their combined velocity was 6.6 meters per second, which is what we had just solved for using the last projectile motion equation. And in order to find out whether or not Souza's speed at the end of his skidding was over the speed limit of 20 miles per hour, we had to use a big fish little fish equation. The equation stated that the mass of Souza's car times the velocity of Souza's car plus the mass of Chuckran's car times the velocity of Chuckran's car equals the combined mass of Souza and Chuckran's car times the velocity of Souza and Chuckran's car. We altered the equations so that we were able to solve for this velocity of Souza's car only. We plugged in all of our knowns and came up with a velocity of 15.3 meters per second, or 34.2 miles per hour. We already knew that Souza was speeding, but we wanted to know whether or not he was speeding before he started skidding. And since he was speeding after he was skidding, this meant he must have been going a lot faster before he had started to skid. We wanted to find out just how fast that really was, and we did that by using a conservation of energy equation. We started with EI equals EF. We then altered the equation so that we were able to solve for Souza's velocity as he was approaching the hairpin turn. We came up with a velocity of 19.7 meters per second, or 44.1 miles per hour. That's 24.1 miles per hour over the 20 mile per hour speed limit. So, with this information, Mr. Chuckran could very easily sue Mr. Souza. And this has been The Road to Suing Souza.